Hello, I'm Jared. Welcome to my stream. I'm a Ruby programmer. I run an agency called Supergood Software where we build e-commerce Ruby on Rails applications using a platform called Solidus. Today, I am working on the Advent of Code Christmas-themed programming puzzles. I've been off the last few days, so I'm catching up. I previously had done up to day 9. Today, I'm going to attempt to, in one sitting, do 10, 11, and 12 if I don't burn out too hard, and then come back later this evening after I've gone for a nice long run to do day 13 at 9 p.m. Pacific. Last day, we were calculating how smoke was settling on the floor of a cave, I believe is what we were doing. Today, who knows what we're doing? I haven't looked. So with that, let's get to it. Day 10, syntax scoring. You ask the submarine to determine the best route out of the deep sea cave, but it only replies, syntax error in navigation subsystem online, all of them. All of them? The damage is worse than you thought. You bring up a copy of the navigation subsystem, your puzzle input. The navigation subsystem syntax is made of several lines containing chunks. There are one or more chunks on each line, and chunks contain 0 or more other chunks. Adjacent chunks are not separated by any delimiter. If one chunk stops, the next chunk, if any, can immediately start. Every chunk must open and close with one of 4 legal pairs of matching characters. If a chunk opens with a paren, it must close with a paren. If the chunk opens with a square bracket, it must close with a square bracket. Same with curly braces and angle brackets. So open close is a legal chunk that contains no other chunks, as is a pair of square brackets. More complex but valid chunks include other things. Some lines are incomplete, but others are corrupted. Find and discard the corrupted lines first. A corrupted line is one where a chunk closes with the wrong character. That is, where the character it opens and closes with do not form one of the 4 legal pairs listed above. Examples of corrupted chunks include sure, and that. Such a chunk can appear anywhere within a line, and its presence causes the whole of line to be considered corrupted. For example, considering the following navigation subsystem. Sure, it's some Lisp. Some of the lines aren't corrupted, just incomplete. You can ignore these lines for now. The remaining 5 lines are corrupted. Sure. Stop at the first incorrect closing character on each corrupted line. Did you know that syntax checkers actually have contests to see who can get the high score for syntax errors in a file? It's true. To calculate the syntax error score for a line, take the first illegal character on the line and look it up in the following table. In the above example, an illegal paren was found twice, an illegal square bracket was found once, an illegal curly brace was found once, and an illegal angle bracket was found once. So the total syntax score for the file is that number. Find the first illegal character in each corrupted line of the navigation system. What is the total syntax error score for those errors? All right. So, as we do each time, I am going to take this sample input. I am going to fail to copy the sample input. It's sort of a ritual at this point. I am going to bump that there. And I'm going to expect to get the same score they did from my part 1. I can bin respect this thing. We get nil. That's expected. Now we just have to solve the puzzle. So I'm going to say input split on new lines dots, and then split on, map line, and then just split it into characters. So we got an array of rows of characters. And we want to write something. So we want to take all the corrupted lines and get their score. So we want to do something lines dot select where they're corrupted, and then sum them using their syntax score, I guess is what we could call that. They call it syntax error score. Sure, let's call it that. Let's use the same words they do. Some domain-driven design here. But of course, arrays of characters don't respond to corrupted, so we probably want to map this into something a little more useful, and I figure we'll just make a line object. So we'll make a line. We know that it takes array of characters, and that it's going to need to respond to corrupted, which we'll say is just currently false, and it'll need to return a syntax error score, which for now we'll call 0. So now we can run this thing. Fails because we expect a big number. We get nothing because none of our lines are corrupted according to our code. So let's just figure out what we want to do with this line. Use the same language they did. We can just use an example line here. I mean, we could just write the test set for all of these. We got examples for context when missing let's just say erroneous square bracket, or sorry, curly bracket. Like that, and we can say it is expected to be corrupted, using some nice RSpec stuff, and we can say, I think we can do its syntax checker score is that's a thing, something like that. I never used this syntax. It's expected to equal, and then so 1197. Okay. So RSpec its. Okay, so it's in a separate gem now. No reason we can't just add it. It's convenient for the style of test we want to write. Now go. Items have described class. Whew. Oh, I see what I did. Superclass must be an instance of class. That's not, what the heck? There we go. It should be corrupted. It is not corrupted. It has the wrong score. And okay, so all this tests we expect to be failing, but for our purposes, let's just focus these tests and not worry about the overall one. So, I mean, I think what we'll want to do here is maybe even in the constructor, do this check here. So let's go grab our Ruby array stuff. Apologies if there's traffic noise. How do we use an array as a stack? Because that's what we need to solve this problem relatively easily. Which one is unshift again? Unshift is, if we consider the first element. So we have push and pop. So push, append, and pop removes the last. Okay, so push and pop are what we can use to use an array as a stack. So we have a stack now. We can loop over. In fact, I don't even think we need to save chars. Not currently anyway. So chars dot each. So we'll loop over each character. If, oh, that's awkward. So our opening characters, opening is that, and then we also have some closing, and that would be those ones. I don't really care. Oh, my mouse is going to die while we're here. I'll fix that in between puzzles, as long as it doesn't die before the end of this. Pour a little more tea, keep me going. It's like mint green tea. Fennel seeds and stuff in it. It's not bad. So if it's an opening, then we push it on. Stack push C. If opening chars dot include C. That's what we're doing. Else, I mean, we can validate here. Else raise unexpected char match equals stack dot pop if match does not equal C. So figure we're going to, every time we encounter an opening, we push on the stack. Every time we encounter a close, we pop off the stack, compare it to the closing one we've got, and if they are not the same, that means we have a syntax error. So if they're not, then we can say bad char equals C is our first bad thing, and we can break. Corrupted then just becomes not bad char. So if there's a bad character, and yeah, so that's corrupted. That worked. We can make our syntax checker score hypothetically work here. So we have our lookup table here. We can just sort of copy that in and reformat it. So just use a hash to, oh boy. Hash like that, and map that over our map our bad char over that, or whatever you want to call that. Words are hard. Seems like it might work. Cool. All right, let's see if it works for one of the other ones and also for one that's valid. So let's try with an angle bracket. So we should be able to take this, shift it here. Now we have an erase angle bracket, delete that line, replace it with a different one. To be corrupted, angle brackets are worth 25,137. So, what am I? Everything passed, but I got it. Oh, it was because this is a paren, not an angle bracket. Looked at the wrong thing. And of course, for parens, we should get 3. What? Yeah, it's definitely this paren. We're getting a curly brace. Intriguing. Let's just focus this one example and see if we can track down why that's happening. The RubyKaigi merge this year was very good. Big fan, big fan. Sadly didn't get to see all the talks. The scheduling's awkward with it being in Japan and everything, but some good stuff there. I mean, let's just look at the state when we get to there. So get to there, match is going to be that, C is going to be that. Oh, that's funny. This characters are supposed to be equal. That's funny. So my logic was very silly. So we actually need a mapping between these. I'm just going to call this parens for brevity. Oops. now we have parens, and so now this is just parens.keys and parens.values, and we want the match to be we can do parens fetch cool. That fixed our failing test. On all of our day. So our day 1 part 1 appears to be working. Or day 10 part 1 rather. Guess we can see if it works. We got the right answer. All right. Day 10, part 1. All right. Now, discard the corrupted lines. The remaining lines are incomplete. Complete lines don't have any correct characters. Complete lines don't have any incorrect characters. Instead, they're missing some closing characters at the end of the line. To repair the navigation subsystem, you must need to figure out the sequence of closing characters that completes all open chunks in the line. You can only use closing characters, and you must add them in the correct order so that only legal pairs are formed and all chunks are end up closed. In the above example, there are 5 incomplete lines. Did you know that autocomplete tools also have contests? It's true. The score is determined by considering the completion string character by character. Start with total of score of 0, then for each character multiply the total score by 5, then increase the total score by the number. Start with the total score of 0, then for each character multiply the score by 5, then increase the total score by the point given. So it's, okay, that makes sense. Sure, I guess. As much as any of that makes sense. The last completion string above would be scored as follows. I won't read through all of that because it's boring. Autocomplete tools are not a bunch. The winner is found by sorting all the scores and then taking the middle score. There will always be an odd number of scores to consider. In this example, the middle score is that. Because they're the same number of scores, smaller and larger than it. Find the completion string for each incomplete line. Score the completion strings. Sort the scores. What is the middle score? Okay. Well, that makes sense, and we can work with that. So we now expect this to equal that number. And let's pop open day 10 part 2. We can also, so we should be able to reuse this pretty well. Instead of lines.select corrupted, it's lines.reject corrupted. We're going to map them to their autocomplete score. And we are going to take, rubies are, is there like a, what? Is there a, can I just take the median? Oh, come on. It would be so nice. Ruby floor. Dot floor. Okay, so that's easy. So in this case, we'll say scores is this, and we want scores.sort scores.length.floor. Sure. I think we'll return to testing our lines here. And we'll do that by picking some lines. Just in order to do this sort of step by step, I'm going to call this non-corrupted line. So it's autocomplete. Now we're not going to use this this method in the actual puzzle, but in order to just get a step further and validate that we're doing this right. We're going to do that. I'm going to remember to type the letter S. And now we should have a no method error or an unexpected. Oh. Why did only that one encounter that? Oh, I guess they all kind of deserve a dot strip in them. Undefined method autocomplete string, that's to be expected. So if I understand this correctly, the autocomplete string is just going to be the characters left on the stack when we make it through this loop, or rather the sort of the inverse of them, mapped through that parens thing. So this is just going to equal chars.reverse.map c parens c. And, or I guess we got to join it. And that way, it's just gonna be autocomplete string. So I think that'll do it. Expected that. Now, why is that not right? Oh, because it's just the current chunk? No, what could I be doing wrong here? Well, let's look at what we're at here. Oh, right. What's this? No, I'm not. It's not making sense to me right now. Let's see. So, oh, it wasn't char.reverse, it was stack.reverse. Grab the wrong thing. So it's what's left on the stack that I care about here. Okay, cool. So that works, and we want to be able to provide a autocomplete score. And the autocomplete score is going to be one. So just make sure that's nice and failing. Is expected. Is not what I meant to type. So score 0. We're going to do something, and then we're going to, so take each character. For each character, we'll do something. We'll forget our do's. And the thing we do is multiply the total score by 5. Score. And then score. String, not the score that we're supposed to loop over. Okay. Well, I got nil out of this thing. Did I save this file? Okay. Scores. Scores dot length. Dot floor. Oh, divided by 2 dot floor. Okay. So we want the floor of half the length. Cool. That's a big number. Nailed it. Cool. That went pretty smoothly. Lots of little bits to work through, but it was pretty fun. Thanks for coming out. I am going to keep going. I'm just stopping the recording here so that I can cut this thing up for YouTube.